Hello guys, it's good to see you. I'm coming at you differently with this video, so y'all will have to let me know if you'd rather see the really nice screen or you kind of like that this is a low-key kind of way to do the video. All right, so what we're going to do this entire week is work on factoring polynomials. So we're going to go through 4 little videos, and then you'll do the My Math Lab assignment in bits and pieces that correspond to the video until you're all done. All right, so our first section is going to be on factoring trinomials using the AC method. But first, let's review big picture. What do we already know about factoring? Remember that whenever you're factoring, you always start with a GCF. And if there is a GCF, you pull it to the front and move forward. And if there's not a GCF, you move forward. One way or another, you always get that first though. After that, when you move forward, it requires that you count the number of terms. So if the polynomial has only 2 terms, you're going to try difference of 2 perfect squares, which you know, or you're going to try the sum or difference of 2 perfect cubes, which is going to be new to you today. And once you learn the pattern, it's pretty easy, but it does take some memorization to get the pattern down. If there are only 3 terms, then you try AC method. And last but not least, if there's 4 terms, you try grouping. But grouping will work for any number of terms, 4, 6, 8, and higher, possibly. So I will show you one later on today with 6 terms just so you can see. But most of the time, you'll be working with 4 terms. All right, so I'm going to erase this recap business, and let's look at our first problem. So you can go ahead and write it down. X to the 4th plus 7x to the 3rd plus 10x squared. Now we're working with higher order trinomial or higher order polynomials, meaning we want to work with stuff that's higher than x squared. We've already done a bunch of x squared stuff. Well, working with higher order is quite often the same idea. The exponents are just bigger. So let me first remind you, we've got to find GCF. And I noticed that I don't have a number that goes into 1, 7, and 10 other than 1, and that doesn't help actually pulling that forward. But with your letters, since you've got x's on all 3 terms, then x squared is a GCF. So let's get that guy to the front. And then I'll have x squared plus 7x plus 10. Well, guys, this trinomial winds up being what you already know to do. So do you remember that what we do is we say, oh, a in this problem is 1 in front of the x squared. C in this problem is 10. That's your regular constant term. So AC is 10. And your B value is 7. And you're supposed to be thinking about 2 numbers that multiply out to positive 10 that add up to positive 7. Well, I could say 1 times 10, but 1 plus 10 is 11, so that's not it. Or I could say 2 times 5, where 2 plus 5 equals 7. That's it. And I bet you knew that from the get-go. So my x squared needs to be recopied. Don't do anything else with it, but you do need to copy it. And then I'm going to say, with this, let me break it into brackets and 4 terms. So the 7x, you rewrite as 2x plus 5x. And then the plus 10. And remember, now that you've got it in 4 terms, you're going to group. So your first pair is x plus 2, because you're pulling out the GCF. This plus sign has to come down. The second pair is going to group as 5x plus 2, again, GCF. Remember, grouping only works if this x plus 2 and that x plus 2, those binomials have to be identical. I'm going to recopy my brackets now on my x squared, because again, this guy just keeps going to the bottom with us. Then on the inside of the brackets, I can rewrite this as x plus 2, x plus 5. You're done. You're welcome to leave the brackets, or you're welcome to drop brackets at that point. And remember, it doesn't matter if you also write it x squared, x plus 5, x plus 2. The monomial needs to go first, but your binomials can go in any order you want them to. So let me mention one more thing while we're at this. Remember, the way to check your work is to multiply your answer back out. So if you're not sure, I always multiply. So if I were to first do FOIL, that would be x squared, 2x, 5x, plus 10. So that's x squared plus 7x plus 10. And last but not least, you would distribute x to the fourth plus 7x cubed plus 10x squared. And if you look, that is identical to your original problem. So I usually don't wait till the end to check. I usually multiply things back out when I'm working through the problem. But remember, that's always a good way to check things, just to make sure that whatever you get multiplies back out and gives you whatever you started with. So now on this trinomial, I'm going to start again. Again, it's an x to the fourth polynomial, which is a quartic, if you remember our degree vocabulary. So I'm going to start by looking for a GCF. I always do that first. And I do notice that 2 goes into 2, 14, and 24. So I definitely pull a 2 to the front. But there's not a letter on the third term, so there's no letter GCF. So I'm going to say that would be x to the fourth minus 7x squared plus 12. Again, I would check and say, okay, 2x to the fourth, yes, minus 14x squared, yes, plus 24. All right, so usually I check by multiplying at different parts of the problem instead of just waiting to the end. That's usually my habit. Now, let's talk about trinomials. To be in a trinomial form that allows you to do AC method, the middle exponent has to be doubled and give you the first exponent. So for instance, if you had ax to the 10th plus bx to the 5th plus c, because you double 5 and get 10, this one is in a form that AC method might work. But if you had some number ax to the 10th plus bx cubed plus c, if you double 3, you don't get 10. So there would be no way that this one would factor in an AC format. You would need something else, which you'll see later in this class. So again, if you had something like ax to the 8th plus bx to the 4th plus c, that would be all right, because if you take your middle exponent 4 and you double it and you get 8, then that means there's a possibility that regardless of what the numbers a, b, and c are, it might factor with the AC method. So you all know that not all polynomials factor, but on the one that I showed you where the middle exponent didn't double to the first exponent, trying AC method is pointless because you're sure AC method won't work in that case. All right, so I'm looking at this and I see that my A is 1 because it's 1x to the fourth now. My C is 12. So my AC is 1 times 12 is 12. And my B is negative 7 with the x squared. All right. So again, now you need two numbers that multiply out to positive 12 but add up to a negative. So it's going to have to be a negative times a negative. So I could say like negative 1 times negative 12, negative 2 times negative 6, negative 3 times negative 4, negative 4 times negative 3. I'm repeating myself, so that's not an option. Of course, if you add these, you get negative 13. If you add these, you get negative, you get negative 8. If you add these, you get negative 7. So that's our set of magic numbers. So I'm going to break this into x to the fourth. For minus 7, let me make it minus 3 minus 4. So minus 3x squared minus 4x squared, whatever the middle exponent, x to the whatever goes here and here, and then plus 12. So 4 terms means group it. So with my first pair, I factor out an x squared. I have an x squared minus 3. This minus sign has to be written there. In the second pair, 4 goes into both of those. And it better be x squared minus 3. So again, right here, I might do a quick mental check. X to the 4th, check. Minus 3x squared, check. Minus 4x squared, check. Plus 12, check. So I'm doing a little multiplication along the way rather than multiplying everything at the end. So now the 2 in the brackets get recopied. I can rewrite this, which is not in factored form because there's a minus sign. If there's a minus or a plus, it's not factored. You can't have any signs between the pieces. So I could say x squared minus 3, x squared minus 4, or you could put the x squared minus 4 first. Oh, look. X squared minus 3 will not factor again. But I want to remind you, you've seen x squared minus 4 before. That's a difference of perfect squares. So remember, x squared is x times x. 4 is 2 times 2. One must be plus and one must be minus. So I'm reviewing with you difference of perfect squares, which will be our next video. And I'm done here. All right, so now we have 6x to the 6th plus x to the 3rd minus 1. All right, my first question is there a GCF? No, I have 6, 1, and 1. So there's no number that pulls to the front. And I don't have a letter on the 3rd term, so there's no x that pulls to the front. All right, so I'm going to go straight into AC method, but wait, can I? Yes, because my middle exponent is 3, and if I double 3, I get 6. So yes, this isn't an AC method format. So I notice that A is 6, C is negative 1, so AC is 6 times negative 1. B is positive 1. So I need 2 numbers that multiply out to negative 6 that add up to 1. So if they multiply to a negative, you have to have a positive and a negative. So I could have 1 times negative 6 or negative 1 times positive 6, right? I could have 2 times negative 3 or negative 2 times positive 3. And those are my only options. So 1 plus a negative 6 is not 1. Negative 1 plus 6 is not 1. 2 plus a negative 3 is negative 1. So remember, if you get the right number but the wrong sign, just flip-flop the sign. So the negative goes in front of the 2 and the positive goes in front of the 3. So that one does give you positive 1. Also remember, guys, you don't have to make the chart. If you immediately go, oh, 3 and 2 or 3 and negative 2 or whatever, there's no point in making the chart. The chart just helps you if you're having trouble spotting it. It gives you a methodical way to go through it. So I'm going to make this 6x to the 6th minus 2x cubed plus 3x cubed. So the 2 middle terms have to both be x cubes because your middle term is an x cubed. Okay, so now I've got it in 4 terms. So let me erase this guy because I want to group the first 2 guys and the last 2 guys. So I'm looking at 6 and 2, and I know 2 is a GCF. X to the 6th, x to the 3rd, x to the 3rd is my GCF. So 2 times 3 and x cubed times x cubed, that would give you 6x to the 6th. And then it looks like I'm going to have minus 1 because that'll give you minus 2x to the 3rd. This plus sign must drop. There's nothing that goes into both 3 and 1, so your GCF is just 1. And I am going to write the 1 there because it helps me with my next step. Furthermore, you know that these 2 sets of parentheses have to be identical. So now 3x cubed minus 1 and 2x cubed plus 1. Well, do I have a difference of perfect squares like I did on the last one? Well, that's not a difference. Well, this is a difference, but 3 is not a perfect square, so you're done. That's it on that one. All right, guys, here we go again. Now we've got bigger numbers. So this is a lot the same thing, but I want to remind you how you can use what I call the slider method to help you when your AC is really big. All right, so I'm looking for a GCF. There's no letter, so I don't have to worry about that part. And 8 and 14 are even, so 2 goes in, but 2 does not go into 15. The only thing that goes into 15 is 3 and 5, and 3 and 5 don't go into 8 or 14. So I don't have a numerical GCF as well. Is this an AC format? Yep, because 5 is the middle exponent, and if you double it, you get the first exponent. So yes, it's AC method doable. If it's going to factor, AC is your right choice. All right, so look, my A is 8 and my C is negative 15. That's going to make AC, if I'm remembering correctly, negative 120. That's a big ol' AC. B is negative 14. Now, I want to remind you that instead of going 1 times 120, 2 times 60, which you could do, you might want to use the slider method. So if you say, all right, right now I've got 8 and 15, I'm not going to worry about signs on the number line. And what I want is 14 between them. But currently, I've got from 8 to 15, currently I've got 7 between them. But I want 14. That means I need to slide 8 smaller and 15 larger. So I need to start trying things less than 8. So I might start out with 8 and 15. Doesn't matter which way my signs are. I'll switch them if I need to. If I go down to 7, I don't think 7 goes into 120. 6 goes into 120, and that would be what, 20 times? 5 goes into 120, I believe 24 times. 4 goes into 120. 4 goes into 120 30 times. 3 goes into 120 40 times. 2 goes in 60 times. So at least my list is smaller. Now I might have not needed to do all of those, because usually if you check as you go, then you can stop sooner. But here I've got 8 plus a negative 15 is negative 7. So again, I knew it was going to be 7. That's too small. 6 plus a negative 20 is negative 4. Well, there it is. All right, awesome. So I don't have to do all of these. So if you'll check as you go, you can avoid making more lists than you need to make, right? So I'm going to rewrite it as 8x to the 10th, and then plus 6x to the 5th, minus 20 x to the 5th, and then minus 15. So here I am again, group, group, group. I see that 2 will come out of 8 and 6, and it will be x to the 5th. So it's going to be 2 times 4 to get 8, and x to the 5th times x to the 5th to get x to the 10th. 2 times 3 will give you the 6. This minus sign needs to be brought down. Here for 20 and 15, I know 5 goes in, and it better be 4x cubed plus, or 4x to the 5th, my bad, plus 3. This is where I kind of double check and make sure I didn't somehow go astray. That's 8x to the 10th. Yep, that checks. That's 6x to the 5th. Yep, that checks. That's negative 20x to the 5th. Yep, I'm seeing that. And this is negative 15. Yeah, I'm seeing that. So I'm on the right track. Just want to make sure that I'm not doing something where I'm kind of acting like it's right, but it's not actually, because I'm not being careful. Now let's make this 2 factors multiplied by each other. So you lose the sign in between. So 4x to the 5th plus 3, and then 2x to the 5th minus 5. Neither one of those is a difference of perfect squares, so I'm done. All right, we just have one more example in this first little video. And you might decide you want to do 2 of the videos in the homework today and then 2 of the videos in the homework tomorrow. Or you might want to like power through all of it today and then tomorrow have an off day. Either way, remember, you can always jump on Zoom and ask me for help. I want to remind you that if you look on Canvas, it says after this first video, you'll do 1 through 10 on the My Math Lab assignment. So I'm chunking it for you. And on the problems 1 through 10, they get a little bit harder as you go, just a little bit, but expect them to build, okay? And that's the same thing with each chunk. We start easier and they get a little bit harder. So you might have 2 or 3 that are kind of the same difficulty, and then they'll jump a little bit, and the next 2 or 3 will kind of be the same difficulty level. All right, so on this one, remember GCF first. You may be thinking, oh, there's not a GCF, but I'm going to remind you, if it leads with a negative, then -1 is your GCF. Pull it to the front. So that has the effect of flip-flopping all my signs on the inside. Okay. Now I look, AC is -14, B is -5. And I bet you're already saying, isn't that -7 times +2? Okay. So I'm going to say -1, then bracket 7x to the 4th gets recopied. On the -5x squared, let's split it in the -7x squared plus 2x squared. And then the -2 at the end. It's 4 terms, so group it. You all are good at grouping, so I know that once you hit this stage, I think you'll be fine. So on the inside, I see 7x squared is my first GCF. X squared minus 1's left. This plus needs to be recopied. 2 comes out here, and it better be x squared minus 1. So I've got -1. On the inside, I have x squared minus 1 times 7x squared plus 2. You're allowed to do a few things. Number 1, you're allowed to say, instead of -1, just write negative. Don't worry about the brackets. If you don't want the brackets anymore, you don't have to have them. If you use the brackets, that's fine too. It's all good. All right. Oh, look what I see. On these, this is not a difference of squares because it's a sum, but that is a difference, and x squared and 1 are both perfect squares. So I do need to divide this guy into x plus 1, x minus 1. And then this guy just gets recopied. So remember, some of them you might do a GCF, AC method, and then difference of 2 squares. That can happen. All right, guys, that's the end of video 1.